Hello everyone and welcome to Linux Forensics here at Pentester Academy. In this video, I wanted to go over some basic information concerning master boot records. In particular, we're going over this now because we're about to mount some images that we created previously. So once again, just an overview of our process. We got a call. Someone said, I think there's been an incident. We said, yes, there has. And we decided to do dead analysis. We've acquired the images, and we're now getting ready to get started with analyzing those images. So the first thing we want to do is mount them. And this makes our life a lot simpler. I mean, we could just examine the files directly and never mount them, but why would you do that? That just seems really hard to me. So if you can mount them and mount them as read-only, you can more easily investigate them. Master boot record is an ancient standard. This came from the 80s. I want to say it's even the early 80s. So it's been around for something like 30 years. And it allows you to have up to 4 partitions. I'm sure at the time that this was first created, they thought, who would ever have more than 4 partitions? You know, who would ever need more than 640 kilobytes of RAM? At most, one of these 4 partitions can be marked as active. That means bootable. It makes sense, right? You couldn't have more than one marked as the boot partition. You certainly could have an entire media with no bootable partitions. Now, if you want to have more than 4 partitions, which people do nowadays, you can use what we call an extended partitions. And we'll talk more in detail about extended partitions in a future video. Extended partition is something that has multiple partitions inside of it, and it stores these partitions in a linked list format. Also, something you should know, this whole MBR thing is old and it's being replaced. It is slowly being replaced with GUID partition tables. So GUID stands for Globally Unique ID. So you might notice that your Linux system has a very long volume name for all your partitions. That's the globally unique ID for that partition. It's set up so that you can have these unique IDs for all of your partitions, and you can store lots and lots of partitions on your disk. And we'll talk more about that in a future video as well. For today, we want to keep it simple and talk about the good old MBR. So what does it look like? A master boot record looks kind of like this. Starts out with 446 bytes of boot code, and then it has its 4 entries. It ends with a signature. The signature it ends with is the bytes 55AA. And that says, I am the end of an MBR. It's also the signature for something called a boot sector that we'll talk about much later in this course. So what is this format? Well, it starts out with 1 byte that contains an active flag. So if this first byte is hex 80, that means this is the boot partition. If it's 00, it means it's not. It then has the start head, the start sector, which is stored in the lower 6 bits of this byte, and the upper 2 bits of this byte are the upper 2 bits for the cylinder, which is stored in the next byte. So the way this works, you have 1 byte, which can store up to 255, and then we add 2 bits. So we have a 10-bit number, so that means a cylinder number in this system can be as high as 1023. So that is how this is done. Now, typically, we don't really worry about this with our Linux systems. Following this information, in the 4th byte, we have a partition code. Now, type 83 hex is the most common that you'll see. That's Linux partition. You might also see things like 8.2 for Linux swap or 8.5 for Linux extended partition, etc. And we'll talk more about those later. Then we have the same information in the same format for the end of the partition, the end head, end sector, and cylinders. What we're more concerned about, it has the sectors preceding the partition, and this is stored in little endian format, and also the total sectors in the partition. So how can I mount an image with an MBR? Well, let's show you how we can do that very easily here on the command line. So here I am on the command line. Now, the Linux fdisk tool can be used on an image file, not just on an actual device. So I will go ahead and I'm going to run this. So I'm going to run fdisk. And before I do that, I'm going to be a little lazy. I'm going to run media, fill. I just want to get my path to an image. Now, this is not the image that we've been looking at, but I just wanted to show you this because this does not have any extended partitions in it. So if I run fdisk on this image file, and I type P for partition type, I will see that this is a type B, which is Windows 95 FAT32. And here's the important bit of information. I really don't even care what this is because Linux is smart enough to mount it for me. I normally don't have to specify any kind of a type. This is the only thing I care about. It starts 63 sectors into this image. So I'm going to go ahead and type Q to quit, and I will make sure I have a place to store this. So I'm going to go ahead and put it, I have a media part1 directory that I've already set up. So I will just type mount, and once again I'm going to mount -O for options. I'm going to mount this as read only, give it the option loop and the option offset equals, and now I have to give it the offset in bytes, not in sectors. So if I'm lazy, I can always pull up my calculator and I can type 63 times 512 bytes per sector, and I see my offset is here. I can copy and then I can paste that in here. I also want to give it the no access time updating. Then I will give it my source of media, fill, Toshiba, disk images, DF 217DD, and I will mount this to media part 0. Boom, done. So if I do an ls on media part 0, sure enough, I have my file system mounted. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.